Imagine we have a power series, n equals 0 up to infinity, an times x plus 1 to the n, and it converges for x is negative 5 and diverges when x is equal to 5. What, if anything, can be said when x is negative 2, if we use x is 4, and x being negative 8. Okay, so we don't have a whole lot of information. I mean, we've got a power series. We don't know its coefficients. We can work out that its center should be negative 1, because that's what makes the x plus 1 to the n expression equal to 0. Okay. And we've got one convergence and one divergence. So how can we work out... I can't just plug in x is negative 2 or 4 or negative 8 here, because I don't know what the ANs are. So any of my tests for series convergence or divergence wouldn't help me. Well, for a question like this, we rely on the convergence disk theorem. And while we could state the fancy technical version of the convergence disk theorem, I prefer to just imagine a number line. Okay? Now, we know our power series is centered at negative 1, so that's where I'm going to center my number line. And we're told about some values. We're interested in negative 2, 4, and negative 8, and we know about the convergence at negative 5 and at regular 5. Okay. So those are the values they talk about. So we've got our center, negative 1, and we've got converge at negative 5. I'm going to actually color code this. So we've got the center here. It always converges at the center, negative 1. Okay. And converges at negative 5, so we'll use green for convergence. And then we're told diverges at regular 5. Okay, now how does the convergence disk theorem come into play? Well, if we know, for example, that we've got convergence at negative 5, if we imagine drawing sort of a circle here around negative 1 that passes through negative 5, and on the other side, so the radius of this circle would be 4. So I guess my picture's a little lopsided. We should actually go through 3 over here. But I don't want to make it green because we can't say that it actually let's move things down and get a real picture going. So 4 here and 5 here. So 3 about here. Okay, so if we draw a little sort of circle here, anything inside this circle, when plugged into our power series, converges. Now, not necessarily at 3. We can't say anything if it's the same distance, a distance of 4. Okay? But anything closer to negative 1 than negative 5 is, and it is strictly closer, okay, will converge. Well, I see right away negative 2 is a convergence. Okay? Negative 2, when we plug in, will converge because it's closer to negative 1 than negative 5 is. Okay? Now, we also know that if we plug in 5, we get divergence. Does the convergence disk theorem help us with that information? Well, yeah, again, if we draw sort of a circle, ours is going to be a little squished because I'll run out of space. That'll be a little bigger. Okay. So this circle centered at the same center, so centered at negative 1. Okay. And that means it will pass through negative 7 over here, so just before the negative 8. Okay. Then anything further away from the center, from negative 1 than this, okay, will have to diverge. But not necessarily as far away from negative 1 as 5 is. So we can't say anything about negative 7, so we'll fill it in with yellow. Okay. What do we see? Well, negative 8 would then be, would result in divergence. Okay. So anything closer than negative 5 converges, anything further away from negative 1 than 5 will diverge. And this is all sort of consequences of the convergence disk theorem. Okay. But we were asked about one more. What about 4? Okay. Well, it's not closer to negative 1 than negative 5 is, and it's not further away from negative 1 than 5 is. So it, like 3 and 7, is something we just can't talk about. Okay? We don't have an answer. And that's okay, because they said, what, if anything? Well, it turns out nothing can be said for 4. Okay? So we get convergence for negative 2, divergence for negative 8, and there's nothing you can say for 4. Okay? Convergence disk theorem doesn't tell us anything, and anything else we would do would rely on knowing what the actual series is when you plug in 4, and we can't say anything with this AN unknown. We don't know what the ANs are, so we're stuck. So we'll say we cannot conclude. And I know sometimes a lot of people have trouble with this, but they asked us a question. Surely you can say something of, no, sometimes you have to recognize the limits of what you know, and we cannot conclude anything for x is equal to 4. Okay? More information would help us out, but we weren't presented with that. So we just have to leave it there and accept that.